Hello and good day, learners. I am Kaysa Capaño, and for this lesson, we will be applying Prim's algorithm and finding the minimal spanning trees. So following the first step in Prim's algorithm, we will be starting the tree with any vertex chosen at random. So for this, I'm going to choose to start with A. Step 2 states that we then look for the shortest edge which joins our chosen vertex on the tree. And similar to cruscals, if there happens to be more than one edge, we would choose them at random. Now we go to B, as it has the least costly edge because 4 is less than 8. And then we proceed to look for the next least costly edges in the vertices. So let us compare the edges where our current vertices are branching out to. So we have BC, BH, and AH, where we will choose the length with the least amount, which in this case is 8, but there are 2 of them, so we will just choose one in random. It doesn't really matter what you choose between the 2 as long as it does not form a circuit. So let's go with BC, and then we will look for our next edge. So we will compare the edges CI, CF, CD, BH, and AH. So here the edges CI is the least costly. So next we have to compare the edges CD, CF, BF, and AH. So we'll be going with CF, which is least costly or has the shortest length. Next we will go with the edges FG, which is the least costly compared to the others. Next, we go with GH. Now, we can no longer add edges AH, BH, and HI in our choices since doing so would make a circuit. So we will instead be choosing edges CD for the next one. And lastly, we have edges D and E. So we now have all the vertices on the tree where the last tree is the minimum length spanning tree. So this is how we get the minimum length spanning tree using Prim's algorithm.